Hi everyone. So today we're going to start with cluster analysis and I'm going to do it in several parts. So in this particular video, you will be able to understand hierarchical cluster analysis, which is first of the three methods which we can employ in SPSS. Okay, so starting with the concept itself, what is cluster analysis? So cluster analysis is identifying groups of individuals or objects that are similar to each other, but different from individuals in other groups. So that is cluster analysis. That sounds too cumbersome. So I'll rather put it in this very simple line, that is organize similar people into different groups. Basically, imagine that you have a data set on different people and these people have rated a particular object or a particular product, say, on several attributes. So that product could have been rated on the basis of its usefulness, on the basis of its price affordability, and so forth. Now, the marketing firm, which has all of this data for all these customers who have filled who have really responded to this data and rated that product on several attributes. Now, this particular data set can be used to employ cluster analysis where this marketing firm can actually identify few homogeneous groups of people. Okay, so few homogeneous groups which can be then accordingly targeted for their marketing promotion programs. So this is like, for example, a group might emerge from the data who is very liking the product. Then there might be a group who is not very satisfied and therefore a repeat sale is not expected from that particular group or cluster. Then the marketing firm can have a policy to really focus on that latter group, okay, with respect to making the performance better, considering their suggestions, and so forth. So that's just one example in marketing, and you won't believe, but cluster analysis is so useful in several other arenas. Okay, so in a nutshell, as I said, that cluster analysis can be put into the simple line: organize similar people into different groups. Now, by similar, I mean I want as much as possible एक जैसा लोग in one cluster. Okay. And about different, I mean that I want one cluster to be very different from another cluster. Okay. That is when I will say that my cluster analysis have been really successful. Okay. So this similar can also be termed as, in very specific to be, in statistics, we say that this is identical to saying maximize homogeneity within a group or cluster. So consider if it's your cluster and it has several other people in it. I'm sorry for the really bad drawing here, but yeah, kindly adjust. If you can imagine these all as people who have been put in this cluster, we want every person in this cluster to be as close or as similar as possible to another person. Okay, so that is when we say that we are maximizing homogeneity within a group or a cluster. And then talking about the different groups, so different groups means I want to maximize heterogeneity between the groups or clusters. Okay, so I'm saying that I want my this cluster to be as different as possible from the another cluster. So that's only possible when, let's say, this particular individual is as different or as far as possible from an individual in this cluster. Correct? So what we want is that two clusters to be very different from each other. However, within a cluster, we want that people should be as alike as possible. Okay. Now, to check for this particular element that, we want to maximize homogeneity within a group or a cluster, we have two different measures. One is called the distance measure and one is called the similarity measure. In similarity measure, it means that how similar they are. And therefore, what would you like? So you would like that the larger the similarity measure is, the more likely are those two cases to become a part of one cluster. Correct? Likewise, you look at the distance measure, that would mean that the smaller it is, that is these two people, the smaller the distance between these two people, more likely are these two cases to be in one cluster. Now, with this particular knowledge, I'm going to take you to the data set which I'm using today. And as I said that this was about cluster analysis. Cluster analysis can further have three types. So we could have hierarchical cluster analysis, non-hierarchical cluster analysis, and then we have, so in non-hierarchical, we have k-means and then two-step cluster analysis. So today I'm going to explore about hierarchical cluster analysis. Before I begin with that, there are several assumptions which you need to be mindful of when using cluster analysis. That means starting with the representativeness of the sample. So your sample should have, such a representation. So basically, you would have understood by now that using cluster analysis, you're going to come up with some clusters. Okay, so let's say you came up with 3 clusters from your sample. Now, each of the clusters should represent minimum 10% of your sample data. So for example, you took, say, 100 people in your sample. So 10% of 100 is 10. So you want that the number of clusters which you have come up with, let's say 3 clusters are the ones you arrived at. So you want that each of these clusters should have at least 10 people. Then we would say that, each cluster is sufficiently representative of the sample. So that's about representativeness of the sample. And then next is impact of multicollinearity. So multicollinearity is quite troublesome in case of cluster analysis. And if it's present, then, include only the variables which are not highly correlated. So that's about that. And then third is that cluster analysis is very sensitive to the inclusion of irrelevant variables or outliers. Okay, so outliers are nobody's favorite, and therefore outliers enter everywhere. So you be wary of using outliers. So that's the third thing. Now, starting with finally the hierarchical cluster analysis, we have this data set. So in this data set, the product is HBAT, and on that product, several attributes, so I'll just tell you. Okay, so I have this product called HBAT, and then I asked several customers to fill a questionnaire which had questions like this. So the question was involving customer type, then industry type, the size of the firm, the region, then the distribution, okay, distribution system, product quality, e-commerce activity. So people have rated on these attributes: the product quality, e-commerce activities, technical support, complaint resolution, and so forth. So as you can see, this is some sort of a marketing survey only. So just like the example I was giving you right now. Okay. Please ignore the last 3 columns. These 3 columns have emerged as a result of my output. So just focus on these first 24 rows. Okay. So looking at the data set, I have my first column as the ID, which you always must have in cross-sectional data. That's a unique identifier in your data. Then starting with the column 2, you have all these variables which have all these labels. Okay. Now, what's your objective? Your objective is to make groups of people. People here being customers. Now, how do you identify those customers? By the unique ID. So you know that you're going to classify people on the basis of this ID number. Okay. So this first person is going to enter some cluster, second person is going to enter some cluster, and so on the basis of all these independent variables. When I say all these, are you going to use all of them? No. Your theory should guide you on which independent variable you use to determine the number of clusters. Okay. So theory is very important in research analysis. Okay. And starting with the fact that I'm going to do hierarchical cluster analysis. So in hierarchical cluster analysis, what we do is that we follow some hierarchy. As the word suggests, we're going to start from n to 1. I repeat, we are going to move from n to 1. That means initially each individual, say individual 1, individual 2, individual 3, and so on, acts like a cluster within itself. Okay, so it's like I have 100 people, and initially when I'm starting the hierarchical cluster analysis starts with the basis that each person is different from each other. So we have 100 different clusters as a starting point. Okay. Then it builds upon the measures. So it employs some measure and then starts combining these people into fewer number of clusters. So gradually we will have, let's say, these people joining cluster 1, these people joining cluster 2, and then these people joining cluster 3, and the remaining in cluster 4. Okay, so that means now you have 4 clusters. Now towards the end, what hierarchical cluster analysis will do, it will try to combine more and more people in less and less number of clusters. So it's going to employ some distance measure through which it is going to combine people into successively smaller number of clusters. So it starts with each person as a cluster. As I said, each person is different from each other. So that's the starting point of hierarchical cluster analysis. And gradually, it's going to build upon this process and end up where every person, literally every person, is a part of one big cluster. I know that's a redundant solution. Nobody would want that, right? So which is why we're going to go with that. Okay, we won't go with a one cluster solution. We're going to stop our analysis at a point where we find that, okay, this, for example, at 3 cluster solution, we might stop, depending upon a stopping rule, of course, which I'm going to explain you further. So, so that's about hierarchical cluster analysis. Specifically, hierarchical cluster analysis agglomerative procedure. So this process which I just explained you of going from n to 1, that is from all people in a different cluster to all people in just one cluster, is called the agglomerative method. So what happens in this method? Each object starts out as its own cluster and is successively joined with the 2 most similar clusters at a time until only a single big cluster remains. Okay, so that's how hierarchical cluster analysis proceeds. And in the next video, I'm going to talk about that now. Thank you for watching the video.